participants to week 38 of Weekend Talk on Safety Engineering Management and Analytics. The event is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. We begin with this event with this beautiful slogan, Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityoma Amritam Gamaya, praying to the Almighty to lead us from ignorance to truth, from darkness to light, and from death to immortality. Let me welcome our dignitaries onto this virtual dais. We have Professor Maiti, who is the chairman of CoE-SEA, Professor O.B. Krishna, who is the convener of the Weekend Talk, and our expert speaker for the day, Mr. Rajneesh Kumar Jain. Mr. Rajneesh Kumar Jain has completed his BE in Mining Engineering from MBM Engineering College, Jodhpur in 1996 and joined the Jharia division of Tata Steel as a graduate trainee. In 2002, he passed the first class Mines Competency Certificate exam conducted by DGMS. He has a working experience of 25 years in coal mining at various positions, including section in charge, ventilation officer, production in charge, mines manager, safety head at Gharia division, mining planning and agent. He has worked for 23 years in underground coal mining at Tata Steel. He has worked for 1.5 years in open cast coal mines for Tata Steel at West Bokaro as head of the mine planning. For the last 2 years, he has been working as safety head of the UG coal mining projects for Gainwell Commercials Private Limited. During his work in the underground coal mining, he has achieved many milestones in production, productivity, and safety. He has received National Safety Award twice from the Honorable President of India for the longest accident-free period at Sinjua Colliery for the years 2007 and 2008. He has also received the Global Safety Award, Green Tech Safety Award, and FIMI Safety Award for improving safety during his period as the head of safety at Gharia Division. Working as the head of safety in mechanized underground coal mining projects of DCPL, he has received the Grow Care India Safety Award for the years 2020 and 21 and the 11th Exceed Safety Award in the year 2021 for the Jhanjra project. CoE-SEA wholeheartedly welcomes you today, sir. We are very privileged to attend to. Now I kindly request Professor Krishna to formally welcome our expert speaker. Over to you, sir.
Thank you, Swin. First of all, I want to tell the participants, the mining engineers who produce the production, they're all experts in safety. Safety, they're one of the highest core competency, especially in underground mines. That's why they can become safety officers at any time. They are in charge of the total safety underground mines. No other external safety officers come. I remember the Tata Steel underground mines were having a lot of problems before 2004, like any Indian underground mines. When Tata Steel took up the safety excellence journey with the help of, say, a consultant, in underground mines also, we wanted to improve the safety to the same as the surface departments in Tata Steel, Jamshedpur. It was a big challenge, big resistance. That people like Rajneesh, who were heading the mining in underground mines of Jharia, they took the lead. And they took a lot of initiatives, which normal underground mine in India cannot take up, cannot think of. The Singareni coal minings, they are all different. They are not metallurgical mines. So these people have taken up all the initiatives, which DGMS himself was not interested to support. like energy isolations and all those things. Even continuous miners, manhandling, man riding systems, all these things. The credit goes to the team where Rajneesh also a team member. And after say 5-6 years of implementing of safety excellence journey in the underground mines of Tata Steel, amazingly, they have become equivalent to the surface departments of Tata Steel. Many years we have run without the underground mines of Tata Steel has run without any serious accident. All those things happened by design, by people like Rajneesh. I'm very fortunate and thankful to him for accepting to speak on this platform. He knows the whole of safety excellence journey of a benchmarking companies, and that is how he could take up. Now in the new organization also, he is heading safety, means he is rightly heading. Safety heading means they will head everything in those organizations. So we'll all be benefited by the talk of Rajneesh, definitely. I hope he will cite some very good examples as a practitioner for about more than say 25 years in the underground mines, and now in one plant. So we are expecting a good Rajneesh from you, good examples also, so that people will take away to their minds and implement it. So over to you, Rajneesh.
Thank you, sir, for introducing me and in a nice manner. Sir, a very good evening to all the participants.
Rajneesh,
today
whole screen is not coming.
Is that yes?
Is it visible now?
Okay.
Yeah.
Okay. Now you go ahead.
So, a very good evening to all the participants. As OBK sir told, the safety has been always been concerned in underground coal mines and even in coal mines. You can see the safety figures of Coal India Limited in 1975. The figures were. Though it has come down to 45 fatalities in 2018, but still the fatalities continues in underground coal mines and all open cast coal mines. If you see the serious incidents also, though there has been a declining trend in serious incidents, in late 80s, the mining were done manually and lots of human interface was there. So you can see the serious incidences were very high, and though there is
Sven, are you able to listen? Are you able to hear?
Yeah. If the connectivity problem is there, then you can put off your video also.
I think there is some connectivity problem.
Rajneesh sir. Yes.
Yeah, go ahead, Rajneesh.
Then can you call him once?
Yeah. I request participants to put off their videos.
Yes. Rajneesh sir, can you hear us?
Coal India itself produced 84% of the India's total coal production. Last year, the coal production of Coal India was 616 million ton. And out of this 616 million ton, Eastern Coalfield Limited has produced around 45 million ton of coal. And out of this 45 million ton, 8.2% of the coal, which is about 8.2% of the total coal production of Coal India. ECL has produced 9.3 million ton of coal from underground coal mines and 35 million ton of coal from open cast mine. And out of this 9.3 million ton, 3.56 million ton has alone been produced by Janjara Colliery Limited of Eastern Coalfield Limited, which is the highest producing coal mine presently in India. So the coal will remain a main source of energy, and there is still a demand of coal will remain for up to stop. So we need to see how the safety we can improve the production and maintain the safety. If you see a typical underground coal mines, the layout, this is the layout of a typical underground coal mines. You can see the surface and the coal seams. Basically, the coal seams found in layers. The layer of these layers of coal is called seam, and the nomenclature starts from top to bottom seam. So in between seam there will be some stone parting. You can see if this is the top seam, there will be stone parting, then another seam, then there will be another stone parting, and this seam has certain inclination. So if at some point of time these seams will outcrop at the surface, and where the seams outcrop at the surface, that area is taken by open cast mine. And where the depth of the seam is less, where from the surface, then the entry to these seams are made through inclines. So the inclines are driven and they reach up to the seams and then start extracting coal from these seams. If the depth increases, as the seams goes deeper and deeper, the depth increases, and if the depth increases, then the shafts are being made from the surface, but the vertical opening are made, and from these shafts the seams are being accessed, and coal extraction starts from the shaft. In every mine you will find there will be two entries. One entry is used for intake and other is for exhaust shaft. So the blue color which is showing is the intake shaft. Intake shaft means the air is, when the persons work in underground, we need to supply the air to them. So for supplying of air, we install one mechanical ventilator over one of the shaft, and this will draw the air from this will basically, these are exhaust fan. So this will draw the air from the underground, and the air will enter through the openings, and this air is circulated to the working area. So in every mine there will be always two entries, one for intake and the other is used for return airway. You can see this discontinuity in the seam. So in underground, many times you will find some faults because of these faults, the seams discontinued and comes up. So wherever these type of faults occur, there will be some geological disturbances, that the disturbances of roof and side will occur. And if the faults occur and if the depth again reduce, then again the entry is made through the incline. You can see this incline has been, if the seam has come up because of this fault, then the access to this top seam is again made through this incline. And in every mine, almost in every mine you will find there will be incline from the surface to the underground, through which either the belt conveyor in the belt conveyor will be installed, and the coal is taken through this belt conveyor up to the surface. And there is another incline which can be used either for material transport or main transport. So this is a typical layout of all the seams in all the area. This schematic diagram is belongs to Janjara Colliery Limited, Janjara Colliery, where the top seam is R6 seam and R7A seam, which is a low height seam. The height of R7 and R7A seam is 1.5 meter only, 1.5 to 2 meter only. So if you extract these seams by conventional mining, there will be a hell lot of difficulty because the person cannot walk on these seams stand. And so these seams have been extracted by a low height continuous miner. And the lower seam, the R6 seam and R5 seam, where we have greater height. So mechanization has been done in these mines. So basically, Janjara colliery comes under Eastern Coalfield Limited, and it has leasehold area of around 1103 hectares and geological reserve is 315 million ton. So Janjara is producing around 3.5 million ton coal production every year. So if you see this rate, the Janjara has a reserve of around 100 more years. So it has a great reserve. The workable seams are the R7 seam, R7A seam, R6 seam, and R5 seam, and lower seams like R4, R5, R3 are the lower seams which are still to be worked out, and these are virgin seams. So Janjara has a great potential of improving production from underground coal mine. Janjara has achieved many milestones. Basically, this project was started in 1985, where the conventional mining was started, and they started producing doing mechanization in 2007-8, where the first continuous miner was deployed in Janjara colliery, and then in 2014-15 they commissioned second continuous miner, and after that they commissioned one high wall mining in R6 seam, and then two low height continuous miner were deployed in lower seam, in low height seam. So altogether, presently Janjara has 4 continuous miner and 1 long wall panel, and it is producing 3.56 million ton of coal from single underground coal mines. Janjara is basically the largest coal producer in India. So if you see in the late 80s, how the coal mining used to be done, as everyone know, coal is an hazardous industry. And in late 80s, basically this coal used to be extracted by drilling and blasting. The person used to do drilling on the face, and then these holes were used to be blasted by putting explosives. So this drilling of hole was done manually, and the blasting used to create lots of hazards of strata control. And the 3-person used to hold the drill and at the face, and the environmental conditions were so hot that the manual drilling used to cause very much fatigue to the persons. After that, when the blasting used to be done, then the blasted coal used to be loaded by the shovel and basket, and this basket loading continues till late 80s, and a gang of 5 to 6 person used to load the coal onto the basket, and then this basket used to be unloaded on the tubs, and these persons were exposed to serious hazards of roof fall, because they were the persons they used to work on the unsupported area. Once the blasting is done, there was suppose if the progress is 1.2 meter, 1.5 meter, these persons used to work under unsupported area, and lots of injury occurred to these miners. And they used to work in a very poor environmental condition, because lots of humidity used to occur on the face, and water seepage were there. So they used to work in a very hard working area. And then these coal used to be loaded on the coal tubs, and these coal tubs used to be transported up to the surface. This was the only means for coal transport up to the surface. So for handling of these tubs also was done manually, and 5 to 6 persons used to haul up the tubs, and there used to be layout of haulages in underground coal mines. And this haulage mining has its own inherent hazards. Many accidents had occurred because of the breakage of rope, because of the derailment of the tubs while lifting the tubs. So, and it was a very labor-intensive method of coal transport. So, lots of human intervention were there. Then, once the blasting is done, the coal is used to be loaded. Then the roof supports were done by timber. Earlier, no steel supports were done, and we used to erect the timber on the roof, and this timber used to get rotten, and it could not take much of load. So lots of accidents occur because of the roof failure because uh, uh, and this timber used to require frequent replacement because in permanent gallery if we support the roof with timber support it used to get rotten over a period of time and frequent replacement of this timber used to be required and no steel was being used in late 80s. So accident rates in late 80s were quite high in underground coal mines as we saw in the graphs also. In late then some of the hazards in old mining days, it was very manpower intensive. The productivity of miners were very less. We used to get overall OMS of around zero point 0.3 to zero point 0.4. And more persons were working in the hazardous areas, so they were exposed to many hazards. The roof support system were very improper because the timber we used to support the roof by the timber and chances of roof and side fall were more and the environmental condition at the face were very poor and more fatigue. It used to cause more fatigue of the persons. Then lots of blasting used to be done for every blasting. For one blasting used to produce only 15 ton of coal, and lots of blasting used to be done. And this blasting had his inherent hazard of fly rock and roof fall and deterioration of the roof. Lots blasting has its own hazards. Then the person used to travel long in underground coal mines by walking, and the roadway is also not clean. There are seepage of water, so lots of slip, trip, fall hazards used to occur in underground coal mines because the traveling distance from pit bottom to the working area used to be around 3 to 4 kilometer and the person used to go by walking and then come up and that too on an inclination of 1 in 7 because the seam has its own gradient. So lots of arduous traveling was there and there was no arrangement for transport of the main up to the face. And this rope haulages has its own hazards. The rope haulage were used for transport of coal from the surface through tubs. So the many accidents occur because the person enter into the haulage roadway and the rope brake got broken and the tub ran away. So it has its own hazards and lots of manpower used to require for hauling of the tubs for transport of coal up to the surface. So in late 90s, some mechanization done in coal mining and where the manual mining was completely stopped and it has replaced side discharge loader SDL. So after blasting, the coal used to be loaded by these SDL machines. But you can see, but these SDL machines were basically crawler mounted machine. So it has its own limitation. It cannot move from one phase to another phase. And these were electrically driven machine. So there was no cable reeling arrangement. So 3 to 4 persons used to be required for handling of the cable. Once the machine is taken back, the person used to the person were deployed for siding of the handling of the cable machine. So they had its own hazards. But still, the manual loading was discontinued and side discharge loaders were put in operation. Then this manual roof bolting, basically this timber was replaced by steel bolts. So we used to drill hole in the roof and put a rod inside that. And that steel rod used to be jammed by cement capsule to support that roof. So this drilling was done manually, and the persons who were doing drilling were exposed to green roof because they were the first person who used to go under unsupported area. So and the lot of dust used to come on their eyes and faces. So it was also very conducive. The environment was not conducive, and lots of incidences occurred to this manual while doing this manual roof bolting. And since the persons were doing the roof bolting, the roof bolts were not inserted vertically. Basically, there is a requirement that the roof bolt shall be drilled in vertically at 90-degree angle from the roof. So, because if they drill vertical hole, the dust will directly come to their eyes. So, they used to drill hole at an inclination of 70 to 80 degrees. So, the roof bolting were not done as per procedure or as per requirement. Then these manual roof bolting were replaced by compressed air drill machines, and this compressed air drill machine used to have one lever where the persons can stand 1 meter ahead of the drill rod. So some improvement was done in the bolting system, but still this requires two persons to operate this machine, and still the hazards remain the same. Though some hazards reduced, but this manual root bolting machine was also required handling of the machine from one place to other place, and sometimes it happens the persons used to enter into the unsupported area because they used to work in the green roof zone. So there were also chances of accidents. Then this haulage mining were replaced by the belt conveyor, and the belt used to be the belt conveyor were installed in underground for coal transport, and this has improved a lot. The safety has been improved because the haulage mining has its own hazards, as I told you. So lots of belt conveyor were installed in underground, and now in almost 80% of the mine, the belt conveyor has been installed and the tub mining has been reduced. Then this SDL were replaced by the LHD machines. These LHDs are tire mounted machine. So, and it has a higher capacity. So this LHD can move from one phase to another phase, and it has high productivity. And these LHDs were having automatic cable reel drum. So no person used to be deployed for handling of the cable. So when this LHD came, the safety also improved, and requirement of manpower reduced because it has a high productivity, and the number of equipment at the faces also reduced, because what happened in during the SDL, because SDL cannot move far away up to 20 to 30 meters, so we used to install chain conveyor right up to the face. But since these LHDs are tire mounted machines, so it can move 50 to 60 meter or 100 up to 100 meter from the face. So the area near the face were clean, and the movement of the persons were safe. So this LHD improved improved the productivity and the safety also. But still, in semi-mechanization also some hazards remain, like blasting related hazard still continued because the coal used to be produced by drilling and blasting. So blasting related hazards still continued, and then the cable handling hazards in SDL added, and there were lots of slip trip hazards, the electrocution of to the persons who were handling SDL cables, because this SDL cable used to be underwater, and if any damage in the SDL cable occurred, it used to cause electrocution also. The roof bolters, since were exposed to green roof, still the roof and side fall hazards remained because the roof bolting was done manually. And roof bolter was also exposed to coal dust, so there were health issues in underground for those persons. Then improper roof bolting with cement capsule. These roof bolts used to be jammed by cement capsules, and the cement capsule has its own limitation. They used to take 8 ton of load only. So the bolting system, the entire bolting system was improper during that time. So lots of roof and sidefall incidences occur because of the improper roof bolting systems. And no scientific study and instrumentation was done for strata monitoring to detect when the roof can fall, how much the load the roof bolt can take, and if so, there was no scientific study done for any of the section for before doing deep layering or development operation. Nowadays, the scientific study is done before starting any of the panel, and they will decide how much the load will be there, what support system shall be there. So in earlier days, no instrumentation was done for strata monitoring, and the environmental condition at the face was very poor, and the fatigue of the persons and long traveling roadway still continued because there was no arrangement of transport of men up to the faces. And rope foliage were, though the rope foliage, the coal transport were replaced by the belt conveyor, but the material transport still used to be done by the rope foliage. So the hazards related with rope foliage still continued in late 90s. Then now in present days in 20s, basically, if you see the if we want to improve the production or the safety in underground coal mine, then the mechanization is the only way by which we can do. If we reduce the exposure of the person at the face, then the safety will improve. And where there comes the state of the art technology and continuous miners have been deployed in underground coal mines. These continuous mines basically require very less manpower. They are very highly productive coal mines, and this continuous miner basically cuts the coal, and the load is the coal is loaded through gathering arm directly onto the shuttle car, and it transport. No blasting is required, and these are basically remote control operated machines. So no exposure of the persons is required is at the green roof area. So in late 20s, in Chandra coal mines, as I told you earlier, they started putting continuous miners. They introduced first continuous miner in 2007, then second continuous miner in 2014, then two more continuous miner in 2018. And one long wall also they deployed in 2016. So with this continuous miner, the mechanization of underground drilling is also done. Now the manual roof bolting has been eliminated, and the drilling is done by this quad bolter or twin bolter, where two bolts can be drilled from by the operator, and the operator is always under the safe area. He is under the canopy, and before he start drilling, there is an TRS, temporary roof support system is there, which supports the roof, and then the operator always remain under supported area. So and no person is exposed to any unsupported zone now. So this roof bolting has been this roof bolting, mechanized roof bolting has improved the safety in underground coal mine, and chances of accident due to roof and side fall reduce. So basically, in any continuous miner package, there is one continuous miner. Then this continuous miners load the coal onto the shuttle car, and this shuttle car basically is a coal hauler. So it transports the coal up to the feeder breaker. And then this, once the continuous miner cuts the coal, the continuous miner can cut up to 14-meter distance. And then this 14-meter needs to be supported. So for that, roof bolter is deployed. And the shuttle car unload the coal onto the feeder breaker, and the feeder breaker thrust the coal and discharge onto the surface. And all these machines are electrical driven. So to supply this power, we have load center. So you can see only 5 machines are required, and this 5 machine can produce 2,000 ton per day coal. And to operate these 5 machines, we required only 5%, 6% in a shift. So you can see the productivity improved a lot, and the exposure of persons reduced, and no person is now worked under unsupported area. So the benefit of mechanized coal mining is higher OMS and less exposure of person in the hazardous area. No persons work under any unsupported area. Only in a continuous miner package, only 50 skilled persons are required, and this 50 skilled person can produce 2,000 ton per day. Whereas in conventional mining, to produce 2,000 ton per day, we require almost 3,000 persons in underground. And no person is exposed to green roof hazards, as the CM is remote control operated machine, so the machine is operated from the remote and no person is exposed to. And the roof bolter and shuttlecar operators, they are always under supported zone. They also don't enter into any unsupported zone. Because the shuttlecar operators himself keep the length of the shuttlecar is 11 meter, and the canopy of the shuttlecar is 3 meters. So he is always under unsupported. He never enter into the unsupported zone. Then, since the roof bolting is done by this roof bolting machine, so the verticality of the roof bolts have been ensured, and the efficiency of the roof bolting and side bolting improved because these machines are being used. And now we are using quad bolter and twin bolter, so 4 bolts can be done simultaneously at one point of time. So the rate of advancement is met by this roof bolting machine, because the continuous miner advances the phase very fast, and we need to match up these pace by this roof support system. So these roof bolting machines are helping and improving the safety. And then now lots of instrumentation is done to monitor the roof. We install rotary telltale at all the junctions, which gives an indication if there is any movement in the roof up to 5 meter, it will start indicating you. There are indicators. If the deviation is suppose of 5 mm, then we need to withdraw the person. So earlier we don't used to know how much load is coming on the junctions. Now, but nowadays these strata monitoring equipments help us in knowing the deviation in the roof. Then we install stress cell and multi-point borehole extensiometer. So lots of instrumentation is done with this continuous miner technology. Then environmental condition improved because this continuous miner requires a good ventilation at the face. So the air quantity at the faces is improved, and environmental condition is also improved. And there is less fatigue of person, because the manual intervention, that the manual drilling, the drilling, blasting, etc. have been eliminated. So the fatigue of person is, there is no fatigue of the person. The machine is operated remotely, and the shuttle car operator and roof bolter operators, they sit under canopy and work only. So in a typical continuous miner technology, you can see this development in the development, only 5 headings is run, and on the center, on the 5 heading, there will be the belt conveyor in the center, and on which the feeder breaker is installed. And if this is the continuous miner, it will cut up to 14 meter. This coal will be loaded on this shuttle car, and the shuttle car will discharge the coal into the feeder breaker. And once this shuttle car goes and it's discharged onto this feeder breaker, the another shuttle car will be taken to this CM, and this will load onto this belt conveyor. So with one continuous miner, we require 1 CM, 2 shuttle car. And once this cut is done and this roof is unsupported, then this roof bolter will be marched to this place, and the CM will be taken to this supported zone, and it will start cutting. And by the time it starts cutting on another phase, the roof bolter will bolt this one. So only you can see we need only 1 CM operator, 2 roof bolter, 2 shuttle car operator, 2 to 5, and 1 feeder operator, 6 persons in a shift, and 1 supervisor, 7 persons. And these 7 persons in a shift can produce 800 ton production. So, and all the persons are under supported zone, no person enter into the unsupported zone. So the safety of the persons improved, because and the productivity become quite high with this continuous miner technology. And 3 to 4 persons are required for maintenance in each shift. So only if in an entire shift, only 10% is good enough to produce. And in one day, these CMs can produce, it produces 2,000 ton per day, 1,500 to 2,000 ton per day. So in a typical continuous miner, when we do development, we normally try 5 headings and keep the belt in center. And this is in other gallery, there is a load center which supplies the power to the other gallery, and then there is a haulage track. If the material is to be transported, this gallery is kept for the haulage track. But if we drive suppose 7 gallery headings, then we install 2 belt conveyors in adjacent gallery, so that this area is developed by this belt conveyor and this area is developed by this belt conveyor. Then once the development is done, then the depillering starts, and I am just showing you how the pillar depillering means the extraction of coal from the pillar. In my previous slide, you can see the pillars are formed. These galleries are being driven, and these pillars are formed, and this pillar is taking the load. But once we do by forming pillar, we make the panels up to the bind boundary, and once the development is completed, we start extraction of taking coal from these pillars. And this is the second stage of the mining, where which we call this depillering. So once this we start taking coal from these pillars, then we allow the roof to fall, and this is called caving. So if we allow the roof to fall, that time the fall shall be controlled in a controlled manner, where we want the fall shall occur up to that point only. So for that also we do lots of scientific study, and they suggest what will be our method of work, what will be the slice length, where we will put the breaker line support. So I'll just explain you how we do depillering in underground coal mines, where the pillar size is larger. This suppose there are 2 pillars, one pillar is and another pillar. Then we have started extracting slices from these 2 pillars. So then after taking slices, the pillar has been divided into 2 parts now. So this is called fender 1, this is called fender 2. Then we start extracting coal from these fenders by taking slices on both sides. So this is slice 1, slice 2, slice 3, slice 4, then slice 2, slice 3, slice 4. So once this area, the coal has been extracted from this area, this roof shall fall. But before fall, it will give indication. So you can see this blue color indication, where this is basically showing the auto warning telltale. We install auto warning telltale in the roof up to a 10 meter. So once the load will come, this will start blinking, and it will indicate the roof. Now the roof may fall. And you can see this red colored dots. Basically, this is breaker line support. Suppose if we are working here, the roof will fall here. We don't want this roof to come in our working zone. So we provide this breaker line support. And this breaker line support is in line with the rib of the coal, straight like this. So this roof will fall, but roof will not come to this area. So our machine will always be at a safer place. And even if after this, we provide some indicating prop over there. So before fall, this indicating prop will give indication the roof will now fall. So we remove the persons and machine from here. So very scientifically this is done now. Now depillering is done very scientifically, and before doing depillering, this entire what will be the length of the skirt, what will be the size of these splits, how many bolts we will put up on the roof, where we will put the auto warning telltale is done by a scientific agency, and then it is implemented. And for every depillering panel has its unique features. So before doing depillering in any of the district now, the scientific study is done, and they will suggest what method of extraction to be done and what method of support to be done. Earlier, we don't used to do this. Earlier, we used to just do depillering in a manner which we want. But now it is done scientifically. So basic safety standards which has been adopted in Jandhara project colliery is the mechanization of the main has been done by drift runner. Now we have deployed free steered diesel operated machines for transport of the main from right from pit bottom to the section. So no manual, no walking of the persons is there now. So it has eliminated arduous traveling in underground. Then the mechanized transportation of the material, as I told you earlier, we used to transport the material through haulage, and the rock haulage itself has its own hazard, inherent hazard. But now these haulage have been replaced with these multi-utility vehicles. So the material is transported in these multi-utility vehicle right from the surface, and it is taken to the underground and unloaded. So no manual person is required for unloading of the material and for transport of the material right from surface to underground. So the entire haulage mining has been eliminated. Only one person, one operator is required for transport of the material from surface to underground. Then deployment of mass production technology. They have deployed continuous miner and high wall mining in coal mines, which is very high OMS. Then high ventilation efficiency in Janjra project colliery. We have two mechanical ventilator fan, and we ensure around 4,000 to 5,000 cubic meter of air at the face. So the ventilation improved a lot on the face. So fatigue of the persons is less, and the productivity of the improved. And we have adopted many safety standards, which is at par with international standard. Our room bolting system, the monitoring of this data is at par with international standard now. But still, there are some basic hazards in underground coal mines, like spontaneous heating and mine fire. Basically, the coal has its tendency of getting spontaneous heating. When the coal is exposed to any air, it starts an exothermic reaction, and it generates heat. So if that heat is not dissipated at one point of time, it may start heating, and if that heating is not detected on time, it may convert into mine fire. So spontaneous heating and mine fire is one of the basic hazards in underground coal mines. Then we start cutting, many times there may be release of methane gas, and some noxious gases may occur. And so inflammable gas and noxious gas is one of the basic hazards. Then strata control is another hazard. Then you may have heard many of time the inundation have occurred in underground coal mine, where if you don't take any precautions with water, so water from one area can enter into the working area. And if we are working in lower seam and upper seam is waterlogged and the roof fall occurred, it may happen the water from upper seam can come to the lower seam and inundation can occur. So inundation is also a basic hazard in underground coal mine. Then dust, lots of dust is generated. So dust is hazards, and thus now because of this caving, there may be some cracks on the surface. So surface subsidence is in hazard. Then blasting related hazards is continued, and slip trip hazards, because many persons have to walk in the working area, and the working area is basically full of muck, water. So slip trip hazards is still there. And fatigue due to poor ventilation. If the ventilation is not good, the fatigue is there. So we take a lot of precautions for prevention of fire and spontaneous heating. So basically, the basic advantage of these continuous miner is that it has a very rapid advance of the coal phases, and the panel extraction is completed within incubation period. Now, what is incubation period? The incubation period is basically the time period between once the coal exposed to the air and till that it give a sign of heating. So normally it is around 9 months in our Indian coal mine. So but since continuous miner has a very rapid advance of the coal phases, so we design the panel in such a way that the panel extraction will complete within incubation period. So chances of spontaneous fire and spontaneous heating is reduced. All the hydraulic oil and used in all these machines are fire resistance, and we use only fire resistance material underground. The loss of coal in GOF is minimized. Basically, what happens if we leave more of coal in the GOF area? GOF area means where we have completed the extraction. Some coal is still left in there. So that coal, because of the poor ventilation, have chances of getting spontaneous heating and fire. So the less is the coal left in the gulf, the more is the safety. So because of this, this continuous miner can take coal up to 4.6 meter height, where in manual mining we used to maintain the height up to 3 meter only. So the loss of coal is minimized, and it reduces the fire hazards in underground coal mine. Then the preparatory isolation stoppings are prepared. Basically, preparatory isolation stoppings are made. If anything goes wrong, we can just seal it off. So it is done. Then precaution against noxious and inflammable gases. We do regular monitoring of mine atmosphere with multi-gas detector and local methane detector. These multi-gas detector are being taken by all the supervisors, and they regularly check it before start cutting. Then our machines, all these machines, roof bolter, and shuttle car are fitted with methane sensor. So if suppose methane percentage goes up to 1%, it will automatically trip the power, and it will give alarm and trip the power. So this methane sensors are interlocked with power supply. So we can know if any release of gases is there. So any chances of sparking is minimized now. Then high ventilation efficiency also ensures so that these gases are released. Then all the blind headings are ventilated by auxiliary fan and underground. And all these diesel operated machines, as I told you, we have started using drift runner and multi-utility vehicle, in which the diesel which is used is of approved type. So chances of release of noxious gases is minimized. Then for strata monitoring, strata management, as I earlier told you, the roof and side fall is the biggest hazard in underground coal mines. So if we minimize these hazards, our safety of the underground safety in underground coal mines will improve. So this conventional mining has been phased out with mechanized mining and continuous miner and long wall miner, where we require very little manpower, and all the persons are worked from the supported zone only. No person enter into the unsupported zone. And now the roof and side support is being done on the basis of geotechnical studies. And now this cement capsule has been replaced by resin capsule. So the roof bolting standard has been improved a lot. And we religiously follow this strata control and monitoring plan. This before starting any development and depilling operation, we conduct scientific study by SIMFER, and they suggest us the strata control and monitoring plan. Then this strata control and monitoring plan is submitted to DGMS. They give the approval, and accordingly we monitor, implement it in underground. And it is since this bolting is done now with machines, so this is very religiously follow. We religiously follow this strata control and monitoring plan. Then side bolting is done with this machine to prevent any incidences, any chances of side spelling. Then quad bolter and twin bolter are used to meet the demand of support for extraction, and with these machines, all the persons work from the supported zone only. And strata monitoring equipments like telltale, extensometer, load cell, and stress capsules are installed in underground. And we take services of scientific bodies, SIMFER, for they are our basically partner for strata control. So SIMFER scientists visit every month also and prepare a report on strata control and instrumentation and strata control. They also suggest which strata control, which strata monitoring instrument to install, where to install, and we do the same, and it is all done under scientific body. Then precaution against dust. This CM is fitted with CM cutter is fitted with water spray nozzle, so dust is minimized. And it is interlocked with cutting drum. So if the water spray will not start, the cutting will not start. So it is already interlocked with cutting drum. Then all this roof bolting nowadays are done with wet drilling. So water is required for doing the roof bolting. So the earlier we used to do dry bolting. So lots of dust used to be generated during drilling, and that dust used to directly come on the roof bolter. But now wet drilling is done, so dust is minimized. And water spray is provided on the feeder breaker, because when the coal crust, there will be chances of dust generation. So water spray are provided, and it is also interlocked with the feeder breaker. And all the persons who are working in underground are provided with dust mask, and they strictly use this. And adequate arrangement have been made for supply of water from the surface for dust suppression system in our working panel. If the CM does not get water at a certain pressure, the CM will not start. So it is mandatory to provide a sufficient water at sufficient head to this CM. Then many of scientific studies are being done before we start development and rebuilding of any panel, like determination of roof strength and support design is done. Then what will be the extraction methodology will be deployed, how much will be the pillar size will be kept, what will be the slice, the size of the slice, how will do depillering, is exercise done scientifically. And determination of physico-mechanical property, capability index, and property of strata is determined, and these data is basically used for designing of the extraction methodology. Then stability of parting between seam and between seam is very important, because sometimes what happen, we are working in a multiple seam, so and if some coal is left on the upper seam, so it and the pillar is left on the upper seam, this pillar will exert more pressure on the lower seams, and the lower seam on those area will get much of load, and side spelling will be then. So while designing this method of extraction on support design, we also take into account what is the status of the upper seam, and where the pillar is left on the upper seam. We designed the roof bolting system in the lower seam to encounter all these problems. Then impact of GOF of upper seam on the working of the lower seam. Ventilation study is done, and determination of gasiness and incubation period is done before we start any new panel, so that we can know, if we know the incubation period, then we can design our panel length such that we can extract the coal before start of the incubation, before start of spontaneous heating. Then lots of training programs are being conducted in mind to improve the skill and upgradation. So all persons are provided initial and refresher training. Then these operators, the CM operator, shuttle car operator, and group bolter operator, basically they require skill training. They are the skilled job, and they are provided training by the OEMs. And our maintenance engineers are also provided training by the OEMs. Then the skill development program is conducted for mine supervisors, official on a continual basis. Basically, in continuous manner operation, the skill of supervisor is very important, because he need to see where the cracks are in the roof, when the roof will fall, where it will fall, when the roof will fall. So skill development is very important. So lots of training program are being conducted for these supervisors. Then we conduct lots of safety awareness program to sensitize persons. We conduct regular safety committee meeting, then contractual safety awareness program, and on-the-job training is provided to all the operators. Some of the safety initiatives which we have taken in Janra coal mines is basically we have started using providing daily safety talk. So every day in the morning, when before start of the shift, the shift in charge will provide a safety talk to his shift employees, and it is recorded in a register. And during the safety talk, they will also take safety place, and we provide regular training on the SOPs. All the SOPs have been standardized. Then life-saving rule, we have framed 7 life-saving rules for underground coal mines, and this life-saving rule are being cited on during safety talk. And I have also made some card displaying the life-saving rule, and these cards, every person carries this card with him every day. And so in these cards contain life-saving rule and safety place both. Then we have a system of capturing near misses. And our employees are now very much aware, and they report near misses, any unsafe act and unsafe condition. Regular safety training classes are conducted, and then internal safety inspections are done, and the compliance being monitored very closely. And technical and operational training are provided by OEMs, and we follow strict compliance of DGMS permission is monitored. So in basically in mining, if you follow there are very strict rules have been framed by Mines Act rules and regulation, and if we follow the DGMS these compliance of these Mines Act rules and regulation, the safety will automatically improve. So you can see the production trend in Janjra Colliery when it started in 1985. It started with 85,000 ton coal per month per year only, but now it has reached up to 3.5 million ton. And in between this, in 2006, they have done mechanization. First, they brought first continuous miner. Then in 14, they brought another continuous miner. Then they deployed this. Drift runner and brought high wall miner in 2016. Then in 2000 eliminated this manual, the metal transfer, two more continuous miner were deployed in 1718. So you can see how they have done much of mechanization, and the production improved from 85,000 to now 35 lakh ton, 355 million ton, and which is the highest producing coal mine in India. And in spite of doing this mechanization and producing a large amount of coal, the accident rate at Chandra has reduced. There has been no fatality due to roof and sidefall since last 2012. Though there has been some serious incidences, or 2 or 3 serious incidences in 14-15, but you see last 5 years there is no serious incidents and no fatality due to roof and sidefall at Chandra Colliery. So the safety has been improved, and this is the only way by doing mechanization the safety can be improved in underground coal mines. Thank you, sir.
Yes, thank you, sir. Thank you, sir, for this wonderful presentation. Now we will take question answer session. So there are a lot of questions in the chat box. I'll take one by one. So the first question is, what type of continuous miners are used at low heights like 1.5 meter? Who are the suppliers?
Sir, we are using Caterpillar continuous miner for low height continuous miner, which can cut up from 1.5 meter to 2 meter. And presently, we have deployed one continuous miner of ICOF also, which can produce, which can cut up to low height continuous miner.
Yes, sir. Thank you, sir. So our next question is, how do the post incident or rescue operations done in the underground manual mines?
Rescue operation, basically in underground coal mine there is a system of having rescue trained person. So every mine which has more than 50%, they have to maintain one rescue team of their own, but they take the help of rescue station. So if any major incidences occur, they need to inform the rescue station, and from rescue station the rescue team will be there, will reach there. But before the rescue team reach there, their own rescue team will become active, and they will take charge of them.
Now, is there any advancement in these rescue systems now compared to earlier?
There is the advance. I will tell there is lots of improvement still required in rescue station. Basically, if you see in India, all these rescue stations are owned by individual companies. There is no central government body which regulate all these rescue stations. Where as I have seen in other countries, where this rescue station is controlled by a central body, government body, and they can provide the help to the individual rescue station. So there is a lot of improvement required in this rescue system in India, and in India still we have not developed rescue during inundation. So still, if there is an inundation, we don't have any rescue team which can go into the water and search the bodies. So improvement is required in that area. We have done some nowadays. The rescue operators have been is improved now, but still some improvement is required.
No, Rajneesh, what I want to know is, see, you have done a lot of mechanization in the Chandra mine, GCPL. Done in this field, they are not doing any extraordinary thing. That's what I want to ask.
No, Janjara comes under Kanusur area. So they have their own rescue station. So Janjara Colliery has its own rescue station. Janjara Colliery does not have its own rescue station. They maintain a rescue room over there, but they take help of rescue station of uh, their ECL Janjara area.
Okay.
Jain Sahab, good evening. This Professor Bhattacharjee. I don't know whether we met each other or not, but
Good evening, sir.
good evening. Good evening. Now I have very good presentation made by you, and you talked about Jhajra and all that. And I am basically from mining department. I don't know whether you know, because the safety officer, the Jhajra, is very well known to me. He also attended our safety course. So my question to you, I first of all, most of our participants are from non-mining background. So I expected you should have thrown, maybe you should have talked a little bit about the safety management plan. That would have been of little bit of more interest, to the audience, because they would have talked about HERA and all that.
So basically, HERA and all that.
And then my next.
Yeah.
Boli.
Basically, the safety management plan has been a part of the safety management system now in all level. But I wanted to present how the mining has been progressed from manual mining to mechanization, and how the mechanization has helped in improving the production, in improving the safety.
Okay. My next question to you, that is what you said. This is what is, I think it will be the reservation from our, I think all the faculty members from the center, that you talked that by maintaining the act and regulations, we can improve the safety, no fatalities, no serious injuries will take place. But if you look at the present views of DGMS, they are telling that those regulatory measures they are described, they are there, prescribed measures. But the mines or the mining authorities or whoever are in control of that, they have to take up self-regulatory measures. And that is where the field of safety engineering and where our center is playing a proactive role. So I thought you may throw some light, what are the proactive measures that you might have taken the contract of extracting those things in Jhajra?
Yes, sir.
Yeah. So what are the proactive measures in addition to the reactive measures? See, basically, what I can say, following rules and they are self-regulatory measures. They are, all prescribed regulation. But self-regulatory measure is that you have to develop on your own, some measures so that you can look at it and, pay attention to it beforehand, before the incidents occurs. So can you throw some light in this area if your company is doing something in this direction?
So basically,
I hope the question is clear to you.
I know. So suppose we have made many good system. Like there is nowhere in the act is written over the person should report near miss as the unsafe act and unsafe condition, and the training shall be provided on SOP, and we shall conduct safety awareness program. So by act it is not in any of the act it is not mentioned. So basically these are some proactive area. If I'm asking about to follow this act, rules and regulation, if we follow minimum of the what has been written in the Mines Act and rules and regulation, definitely the safety will improve. But in addition to this, the awareness of the people needs to be improved, and for that we have taken many proactive actions like improving safety awareness amongst them, framing of life-saving rule, citation of safety pledge in under before starting of every shift. Lots of training we arrange training from the OEMs to improve their skill. So lots of initiatives are being taken to.
No, do you have some type of databases like, DuPont, they came up in a big way and they did lot of work. I think Professor Krishna knows it much better than me, in mining and as well as in non-mining division and all that. They came up with a safety information system whereby even I could right now, they came few days back. Sitting here, they can see what is happening in their mind, and accordingly, they can guide the concerned person. So have you developed items like that, which is basically the state of art?
Yeah, if I tell you, basically, if you know about Genwell is not a mining company. Genwell was not a mining company. It was into Caterpillar business. So when I came in,
yes.
It was into Caterpillar business, and the safety as a whole was not taken very seriously when before my joining over in this company. So when I took over as a head of safety of underground coal mine, and I've been given a special charge, then I started making systems of capturing near misses, unsafe act and unsafe condition. Earlier, the people were not knowing and the importance of the same. So now all the employees are trained on near misses, all the employees are trained on unsafe act and unsafe condition. Now they are starting reporting. Earlier, there was no online system of reporting of incidences. Now we have made incidents reporting system, online incidents reporting system, where people can log all unsafe act, unsafe condition, near misses reporting in online. Earlier, when I came, then the SOPs were not in a standardized format. Though there were some SOPs, but they were in a haphazard manner. So all these SOPs have been standardized in a standardized format. So lots of initiatives have been taken to improve the safety culture in this company, and since last 2 years we have got 3 safety awards within 1 year. So we have got GrowCare India Safety Awards for 2020-21. This year we have received 11th Exit Safety Award. We have also participated in CIA Safety Award, where we have been given star rating 3 certificates. So lots of initiatives have been taken. Proactive action has been taken in our company.
Let me tell you, we are doing extensive study for 3 continuous miner work site in SECL. These are they use safe technology, but lot of incidences are happening because of this under the category of reportable near misses. And even some of the serious injuries like fracture, it is not being reported by the management. But as our study is primarily, field-based study where we conduct the interviews of the workers or we ask them, we found out they had a fracture, but it was not reported as a serious injury. So it was a gross violation, I would say.
Basically, our company, when I joined as a head of safety, none of the incidents is being hidden now, because I came from a Tata Steel environment. So I know, and there are many incidences. We have our own system of capturing incidences and reporting of near misses. And we are into Caterpillar business, so we need to send these reports to Caterpillar. At the end of the month, at the beginning of every month, we need to send our monthly safety report to our Caterpillar. And they also monitor this.
My last thing, I feel there is a scope for collaboration with our center,
Sure.
So we can discuss later. You can talk with Professor Maiti. We'll make your company's attitude towards safety as well as the Jhanjra project or whatever future projects, You'll come up with a state-of-art package.
Basically, this Jandra project has been a flagship for our company.
Yes.
And this has become benchmark, and now we are taking other projects, other contracts, because we have done good job in Chandra. So this is our flagship project.
Yes. So that's all very good. Otherwise, very good. So that's okay. Thank you.
Professor Maiti, you want to say anything? Professor Maiti?
Yeah, no, actually, I only thank Mr. Rajneesh, and actually I could join a little later because of some other engagement immediately, and so I have not listened the entire part. But what I understand from the later part of the your talk, that you are focusing more on two aspects. One is the behavioral aspects and the technology aspect. And obviously, we really appreciate your views and your experience in this particular domain. It's enormous, and definitely, as Professor Bhattacharya mentioned, that we'll be happy to be working with your company, and also we need your support and help.
Sure.
Yes, Professor Krishna, this much from my side.
Yeah, Rajneesh, I seek one or two clarifications from you.
Yes, sir.
What Professor Ashish Bhattacharya was talking about is, are you into IIoTs or Industry 4.0 systems where you can have put the sensors for getting data and decision making using some analytics? Because you're doing a lot of mechanization, then why don't you get into these areas also, which will help you for taking decisions very effectively, for getting the feedback of the all abnormal things very quickly.
Sir, presently, as I told you, SIMFER is our scientific body, and which is our partner for strata monitoring. So what happened? Basically, DGMS also relies on any government body. So when we submit report, when we conduct a study from the SIMFER, they also do not object for anything, and they suggest the instrumentation and. We regularly monitor the strata monitoring readings and send to them, and every month they prepare the report for SIM. So presently we are taking services of SIMFER, but definitely we can take help from your organization also.
I mean, not only you see, this is the area of using the technology. Technology and decision making.
Definitely we can.
Yes, that is also my concern. Yeah. Okay.
Actually, we want to tell Mr. Sundaraman, Tata Steel Mines, to get into this area slowly. We'll get in touch with because that was my concern when I was in Tata Steel. Now, many other places it is improved across the Tata Steel, this Industry 4.0 and the analytics, all these things. But I think underground mines, has not yet entered it looks. Okay, good. And Tata Steel Mines also went into all these continuous miner in all their mines? Any idea?
Sir. No. Only they are deployed only in one underground coal mine at Jamadoba. Tata Steel has already stopped their two underground coal mine. Are you aware?
Okay.
They stopped production from Jamadoba and 6 and 7 pits quality. Only 3 quality is being run now.
Okay.